This is Max Headroom, and what you're about to witness is one of the most sinister-sounding intros to a trailer to one of the greatest epics ever produced in the history of television. And there's more, because you are going to see it as well.
Yes, it.
Yes, it. Yes, namely...
Geometry. That's right. This is the review. We're going to look at our Chapter 6 review, and I'm going to work the whole thing this time. I know earlier I had done a little bit for some review problems for the first or second before the first quiz, but I'm going to work out the entire practice review for the exam. So let's take a look at it. Let's get to our first problem. Okay, our first problem talks about the coordinates. When the coordinates 1, 1, 7, 3, 8, 0, and 2, 2 are joined, what shape is formed? All right, so if we go to Desmos.com, we can put these points in here and see what shape it makes. If we hit the little plus button up here, it gives us the choice of putting in a table, which we can put these points in as a table. So let's do it this way. So we have the first point, 1, 1, and see it'll place that on our graph right there. You see the green dot up here. Our second is 7, 3. And then our third point was 8, 0. And the XY for our last one was 2 and negative 2. So we see them on there. We can also go to this little gear, this little settings right here, and we can tell this. Where is it at? Right there. When we click on the green, we can tell it to add the lines, and it will connect those. And if we wanted to connect back to the beginning one again, we can just add that first point again as our last point, and it'll bring the line back and connect. So we can see, move that over there, we can see that that is obviously a rectangle, 90-degree angles. It's like these have the same slope on the sides and the same slope on the top. So this is a rectangle. So we can see that by graphing it electronically, or we can graph it on paper the same way. If you want to print out some graph paper and just put those points on there, you can look at it, see that way. You can also use the slope formulas and check to see that the slopes from here to here is a opposite reciprocal of the slope of the sides. And you'll see that they have the same slope on top and bottom and the same slope on the left and right. And those are opposite reciprocals. The slope here is 1/3, and this is -3/1. And so since those are opposite reciprocals, we know that's a 90-degree angle. And we know the sides are parallel, so that also makes it a rectangle. So there's more than one way to solve this, whatever works for you. That means we're going to check a rectangle right there. So we said, the slope of the one was 1/3, and the other was -3/1. Those are opposite reciprocals. One's positive, one's negative, and the fraction is flipped upside down. That's opposite reciprocal. So just a refresher on what those mean. Okay. A triangle that is considered equilateral. Equilateral. And I'm going to highlight that equa part of there, that prefix. Equal, it does mean what you think it means equal. So for equal, that's the same thing as congruent. All three sides have to be congruent for it to be an equilateral triangle. Lateral is distance. So all three sides would be the same distance. Three sides congruent is an equilateral triangle. Okay, so quadrilateral ABCD has opposite sides that are parallel. Okay, opposite sides are parallel. So that means right away we're dealing with a parallelogram for sure. And side AB is congruent to DC. So these are the same length. We don't know for sure if it's a rectangle or whatever. We just know that this is the same length from A to B as it is from D to C, right? Same length, and we know these are parallel, and it said the opposite side, so these are parallel. If these are the same length, these have to be the same length. There's no way that these could be different. If these are parallel and exactly the same length, that's going to make these parallel and the same length automatically. So in that case, do we know if it's a square, rhombus, rectangle, parallelogram? This could be any, because we don't know the lengths, but since it didn't tell us we have 90-degree angles, we have to know for sure those angles are 90 degrees, and nothing told us that. We don't know if it's a rectangle or square. And a rhombus, all four sides have to be the exact same length. It's just like a square. It's just slanted like this. All four. It does not tell us that all four sides are congruent. So since the only thing we know for sure is the opposite sides are parallel and that the two sides are congruent, we know it's a parallelogram. The rest of it, we do not have enough information to determine that. So we can only choose parallelogram in that case. All right, let's move on to number 4. The distance formula can be used to prove the quadrilateral has what? A right angle, congruent angles, parallel sides, congruent sides. Will the distance of anything tell you the angle? No, it doesn't tell us if it's the right angle or congruent angle. Nothing about that will tell us anything about the angles. How about the sides are parallel? The only way we know sides are parallel is if we know they have the same slope or not. Distance does not tell us the slope. It only tells us the length of the sides for a quadrilateral. So we're looking at congruent sides. Okay, let's look at number 5. Line AB has the points -6, 3, and 2, -5. So it has a slope that is what? Okay, well, we have the slope formula where we have the slope equals the difference in the y's. You take the second y, subtract the first one, take the second x and subtract the first one, and that'll give us the slope. So let's just do that. So our x's are -6 and 2. Don't get that mixed up. Don't subtract the -6 from the 3 because one is an x and one's a y. So you got to keep your x's and y's. So remember the y's go on top and x's go on bottom. So let's keep that straight. So we have -5 minus 3, right? Minus. And the second x is 2 minus -6. That is a negative. We're subtracting it. So -5 minus 3 is -8 because it's even a bigger negative. But 2 minus a negative is the same thing as a plus. So 2 plus 6 is 8. So -8 over 8, or -8 divided by 8 is -1. It has a slope that is negative. It has a slope that is negative. Okay, it's just wanting to know if it's positive, negative. We didn't really have to calculate that. We could have taken a graph if we wanted, and we could have said -6, 3, -6, 3 is right there, and 2, -5 is over there. Just looking at that, we know the slope has to be negative because it goes down and it goes to the right. So there's more than one way to answer that. But since we have the slope formula, we need to get used to using that. This one, we have to use the slope formula because it wants to know a specific slope. All right, so we'll do it just like we did above. So the slope equals 8 minus -2 over 1 minus 3. So 8 minus -2, 8 plus 2. 1 minus 3 is a -2. So 10 divided by -2, or 10 over -2, is a -5. That is the slope of those 2 points, -5. All right, if I go too quick, remember you can always back it up. This is a video, you can pause it, anything you like, just to make sure you're understanding what I'm doing. I'll continue on. So line BC has these points, 4, -5, and 3, 2. DE has 2, 0, and 9, 1. So it wants to know, are these lines parallel, perpendicular, or neither one? All right, well, let's find out the slope. Slope of BC, 2 minus -5, and 3 minus 4. 2 minus a -5 is 7. 3 minus 4 is -1. So this slope is -7. All right, and then the second one, the slope is 1 minus 0, 9 minus 2, 1 over 7. So this one has a slope of -7. This one has a slope of 1 over 7, and it's a positive. This is the same as 7 over 1. So these are opposite reciprocals, because in reciprocals, you just turn the fraction upside down. 7 becomes 1/7, negative becomes positive. These are perpendicular. They make a 90-degree angle because their slopes are opposite reciprocals. Opposite reciprocals. -7 positive 1/7. All right. The equation of line AB is y equal 5x plus 1. And they want us to write an equation, okay, parallel to AB in slope-intercept, which is this is slope-intercept, y equals mx plus b. But it has to contain this point, 4, 5. So the best way to start out is to do the point slope, where we take y minus the y of that point equals the slope times x minus the x of our point, right? So this 4 would go right there's the x. Don't get those mixed up. The x is the first number, but it's second in the equation. And the y would go right there. And then slope, we've got to figure out what is our slope. So our slope, m, in a y equals mx plus b, the m is right before the x, so it's 5. So let's write our equation. Y minus 5 equals, our slope is 5 times x minus 4. All right. Color coded that, so you know the 5 goes there, the 4 goes there, the 5 from the slope goes there. Now we need to take this equation and make it a y equals, which just means we solve it for y to get y by itself, just like this. So order of operations, first we've got to get rid of the parentheses. So y minus 5 equals 5 times x is 5x. 5 times negative 4 is negative 20. Oops, I got rid of the parentheses. Whoa. Okay. We get rid of the 5, move it to the other side. So y equals 5x negative 20 plus 5. And there it is, right there in the first choice. Y equals 5x minus 15. So we just substitute in the point slope, and then we simplify it down to y equals and put it back in the slope intercept form, using the point and the slope from that equation. All right, find the y value for the point that splits EF in half if E is located at 5, negative 2, and F is located at negative 1, 3. Now, again, you can graph those and try to find the middle, but this is a simple thing. If we look at it, the y goes from, they want the y value only, so it goes from negative 2, just think of a number line, negative 2 all the way to 3, right? So how far is that? So negative 1, 0, 1, 2, 3. It is a distance of 5. If we subtract 3 minus negative 2, we know that is a distance of 5. That's how long that goes on the y-axis. From this point to this point, it goes 5. That's up and down, right? The y is the up and down. So it goes up and down 5, distance of 5. If we wanted to find the middle, we take 5 divided by 2, 2.5. So we should go 2.5 from either end to get to the middle. Negative 2 plus 2.5 would put it at 0.5. Or 3 minus 2.5, because we're going to go towards the negative direction. 3 minus 2.5 would also put us right there. So the y value is 0.5 of the point that would be in the middle between these 2 points. We can find the x too if we want to know the whole xy coordinate. But right now, all it asks for is the y. We know the y is 0.5. All right, next problem. Point A is located at 0, 4. Point B is at negative 2, negative 3. Now they want the x value for the point that is 1/4 of the distance from point A. From point A, you got to pay attention where they're going from, because if it's not right in the middle, you got to figure out which end are you starting at. From point A, which is 0, 4. Okay, and they want the x. And so it starts at 0, and it goes to negative 2. So it's going this way, negative 2. So we know that's a distance of 2, right? It goes from 0 to negative 2. It traveled 2. It traveled in the negative direction. And they want to know the point that's 1/4 of the distance. We're going to take 2 and multiply it by 1/4. Right? So 2 times 1 is 2. That's 2 over 1. 2/4, which is 0.5. You can do that with a calculator if you like. You take 2 times parentheses 1/4 Say I put 1/4 in parentheses, 1 divided by 4, and it's 0.5, right? So we know 1/4 of the distance is just a half. So the x value starting at A, which starts at 0 and goes towards -2, starts here and only going 1/2. This is the distance we're going. It's a -0.5. That is 1/4 of the distance from the 0 to the -2, right? Half the distance would be 1. 3/4 of the distance would be -1.5. I mean, -1 and -1.5. So just look to see where you're starting at so you know which way to add that to, right? Makes a difference if you start at the -2 or if you start at the 0. So look at where they want you to start from there. All right. This is similar, but a little bit different. Still finding the x value for point C. Now, C is going to exist when we put it somewhere. So that AC and BC, so that means somewhere on that line we would put a C. We don't know where, but somewhere we would put a C. That would form a 2/3 ratio. Now, this is important to look at the order. The 2 goes with AC, right? And the 3 goes with BC because that's the order they list them in. They list this one first, so it gets the first number, this one second number. So that means a 2-to-3 ratio. That means we're adding it together to figure how many pieces there are. That means there's 5 pieces altogether. And AC is going to get 2 of those pieces, and BC is going to get 3 of those pieces. It's kind of the way I think of it. If we broke it up into 5 pieces, 2/3, 2-to-3 ratio, you get 2, you get 3. That's a 2-to-3 ratio. So they just want x values. So where do we start? -3 is the A, right? And this is at +3. So that is a distance of 1, 2, 3, 4, 5, 6. This is 6 long. And we got to break it up into 5 pieces. So 6 divided by 5 is 6/5, right? Which is really just 1 1/5 for you folks that don't like the improper fractions. 6/5, and we need 2 of them to go from the A. So 6/5 times 2 over 1, 12/5. If you're wondering how to put that in a decimal, just take 12 divided by 5, 2.4, right? So, or 2.4, because they have it in the decimal over here. So we need 2.4. So we start at -3 and we go 2.4. So -3 plus 2.4. All right. So you can do that in your calculator if you like. -3. Not clear that up. -3. Sorry, I don't know where the negative is on this. Oh, there it is. -3 plus 2.4. -3 plus 2.4 is -0.6. -0.6. So somewhere along here is where C is going to be. Somewhere right in that area right there. About -0.6. So probably going to be like 3 where the Y value would be, but -0.6. So we just divided it 6/5, 6/5, 6/5, and 6/5, where each one of those is 6/5. And we gave 2 of them to where the C would be right here. 2-to-3 ratio. 2-to-3 ratio, because this is A and this is B. So AC gets 2/3, BC gets 2/5 and 3/5. I'm sorry. 2/5 and 3/5. All right, let's look at number 12. Find the perimeter of the following shape. So the perimeter is the distance around. We just add up the sides, but we need to know how long these sides are. All right, so our distance formula, where we take the square root of x minus x, x2 minus x1 squared plus y2 minus y1 squared. Okay. So let's check the distance from A to D. A to D. Square root of the x is 7 minus the x is 4 squared plus the y is 5 minus the y is 4. Take it across, 4 squared. So distance is square root of 7 minus 4 squared. So 7 minus 4 is 3 squared plus 5 minus 4 is 1 squared. The distance equals 3 squared is 9. 1 squared is 1. 9 plus 1. So that is the square root of 10. This distance is the square root of 10. Now, if we look at this, this is a parallelogram. This is a parallelogram. So I don't have to worry about doing this one. It's going to turn out exactly the same. You can go ahead and calculate that. 6 minus the 3, which is still be 3, and the 3 minus the 2, which is still be 1, and you're going to get the square root of 10. So both of those square root of 10. These should be the same also, being that this is a parallelogram. So let's calculate one of them. Let's do C to D. Square root of what is our x here? It's 4 minus the x here is 3 squared plus, what's the y? The y is 4 and the y is 2. Distance formula. 4 minus 3 is 1 squared plus 4 minus 2 is 2 squared. 1 squared is 1, so that's 1 plus 2 squared is 4. So the distance is the square root of 5. So this is the square root of 5, and this is the square root of 5. So let's add all those up. We have 2 square roots of 10 and 2 square roots of 5. Well, that's not how they gave the answer. They gave it in decimal. So we're going to go ahead and pull the calculator out. And let's add those up. So if I use the second button, there's usually a square root with the square. There's square. So square root, see the square root of 5, square root of 5, plus, and I'm going to do square root again, 5. So I've got 2 of those. And then I need to add 2 of the square roots of 10. So second square root 10. There's 1 plus another square root of 10. So there's 2 square roots of 10 plus 2 square roots of 5. And then equals 10.796. That would round to 10.8. So this here is the perimeter, or the distance around that parallelogram is 10.8. All right, last problem. Segment BD is an altitude of triangle ABC. ABC. Find the area of the triangle. Well, the area of a triangle is 1/2 base times height, or you can also say area equals base times height divided by 2. Those are the same thing. 1/2 times or divided by 2, either way. All right, so we'll just use this one, divide by 2. So the base times the height. Well, where's our base? If this was a 90-degree angle, then we could say this was a height, but it's not. It doesn't say it is. So, okay, it tells us this is an altitude. If that's an altitude, then this is a 90-degree angle, because that's an altitude. Altitudes are a 90-degree angle from the vertex at the top. So we know that this is the height. So how tall is that? 1, 2, 3. Those are all points that are on the line, so we can just count them as a height of 3. And how long is the base? Since this is the height, this is the base. 1, 2, 3, 4, 5. Okay, so height of 3, base of 5. Area equals base of 5 times the height of 3 divided by 2. 15 divided by 2, which is the same as 7.5 as a decimal. There we go. 7.5 is a decimal. That's it. We're out of problems. All I have is some graph paper left that I was showing you that on there. So, review this. Take your time. You can do the test, right? The test should be problems similar to that. Shouldn't be any harder than that, I would hope. So if you understand this really well and can ace the practice test and do really well in the practice test, you should be ready for the unit exam. So do work you can be proud of, and I'll see you next time.